Good morning, my dear students. Today we are going to discuss on the topic Poisson distribution. Let's discuss first binomial distribution. We already learned the binomial distribution. We know that there is a Bernoulli trial. Bernoulli trial means there a random experiment in which there are two outcomes. The outcome, every random experiment in which there are only two outcomes, such type of activity, such type of experiment will be treated under the head Bernoulli trial. Then for our convenience, we will say that the one is the probability of success and the another one is the probability of failure. The probability of success will be given as P and the probability of failure will be Q. These two are the small letter P and small letter Q. Then the total probability of this success and failure will be is equal to 1. This is our assumption which we used in the binomial distribution, and we know that the binomial distribution is having the probability density function PDF. The PDF of the binomial distribution f of x or p of x, whatever we can give it as p of x, and we know that NCx into p raised to x q raised to n minus x. Okay, this is our already we learned this combination term. Combination means number of times you conduct the experiment, and x is the favorable time which you want, and the p is the probability of success and the q is the probability of failure. This the function you will get the value of the binomial distribution. We already discussed in our last class. Now we are moving to discuss about Poisson distribution. And coming to the Poisson distribution. The Poisson distribution was introduced by Simon Poisson, a French mathematician. Don't call this name as Poisson. It's just Poisson. You have to tell it as Poisson. It's a French. If you pronounce by the French, it may be something different, but according to English pronunciation, you have to call it as Poisson. Then the French mathematician has introduced this concept in 1781. It's an extension, it's an approximation to the binomial distribution. He has did some approximation in the binomial distribution. Then usually the binomial in Poisson distribution, it is used for the occurrence are in independent. The chance of occurrence of a random experiment is independent, and the occurrence of the same and also the occurrence are in random, and the probability of occurrence is constant over time. In these three cases, we are using the Poisson distribution. For your understanding purpose, I will say that cases I will discuss here. That I will discuss the cases. Then I will come to the cases examples. If you consider the case of an industrial accident per month in a manufacturing plant. For example, a manufacturing plant is located nearby you and there are accidents. It's just very less number of accidents are happening in the industrial estates or industrial zones or industrial area. Then according to the total number of accidents per month, it may be less than 10. It may be less than 2. Then this type of cases, the chance of occurrence of the event is very small. Then such type of cases you can apply the Poisson distribution. And you consider the case of number of telephone calls in a week. You take the weekly in your home or in your phone. You can see that you are getting telephone call from others, and we are not talking to other people in 24 hours or 24 into 7 hours. Okay, then we are getting some calls only, but that can also be identified by our call logs. This type of case also coming under the experiment. The chance of occurrence of the event is small in that case also. Then and consider the accidents in a road accident, accidents in the road. There also chance of occurrence of the event is very small. Then there we can apply the Poisson distribution. These are the different cases of applying the Poisson distribution. Once again, I will tell you The reason for applying the Poisson distribution is the chance of occurrence of the event is very small. In that case, say for example, the chance of occurrence is less than 10%, then we can apply this Poisson distribution. Whereas in the case of binomial distribution, the chance of occurrence is high. The chance of occurrence is very high, like it is P and Q. We know the P and Q. P is the probability of occurrence of successful outcome, and the Q is the probability of occurrence of the failure outcome. These are the prominent outcomes. But here in the case of the Poisson distribution, this chance of occurrence of a particular accident, particular event is very less, and this term P is very small. In such case, we can apply the Poisson distribution. And coming to the equation part of the Poisson distribution. Then usually in mathematical term they will use lambda as a factor. This is lambda. This lambda is used there. But for we are commerce people, we are not using such type of symbols. Then our factor, we call it as m. Instead of this lambda, we call it as m. M is the mean. M is the mean of the random experiment. And also this I will write the equation, probability density function of this. Okay, then probability density function p of x or f of x is equal to e raised to, e is the expectation, e is the exponential series, e raised to minus m raised to x divided by x factorial. This is the Poisson distribution function. Here m is the mean, x is the number of times that you want to get the favorable outcome, and e is the method, just like logarithm. E is also an exponential series. If you have a scientific calculator, in your scientific calculator you can see the e raised to minus dash is there. Using that function you can find out the value. Instead of this, if you have a logarithm table, you can check the value of the exponential series there. Then x factorial, we already know that x factorial is just like 1 into 2 into 3 into etc. into up to x. You are taking the values, the product sum, the continuous product sum, then this is x factorial. This is our equation for the Poisson distribution. Then coming to the mean and variance of the Poisson distribution. Mean and variance of the Poisson distribution is mean is equal to NP, and the variance also, that is sigma. Variance is sigma. The sigma is also NP. The both mean and the variance factor are same here. Okay, some problem with my screen. The same equation, that m is equal to NP, that n is the number of times the activity is conducted, and p is the probability of success. Probability of success here means happening of industrial accident. If a bulb manufacturer, of a bulb found that there are out of 1,000 units of bulb produced by them, there are 10 units found to be defective. That is a probability. That is, out of 1,000, the 10 is the probability. That is p here, and n is the number of times that event is occurred. Then m and variance sigma are the same for the Poisson distribution. Let's coming to the some of the example. Application problem. Okay. We will be discussing this in the next part. Thank you.